Oh, thank you for sending me the things.
Oh, no problem. All right, today we are talking about just more examples of deriving inverse trigonometric. Today's the 28th of February. It's March tomorrow. And we are deriving with inverse trig functions. And it turns out all I had on the agenda today is more complicated examples of them. So, first, any questions from yesterday's that weren't covered in by you guys coming by at lunch or anything like that? Yes, no, maybe? Nope. Tyler, think you're good at that? Okay, let's move on to the more difficult ones then. You guys are just going to give me hints on how you think these should be handled. Okay. First example. Y equals 25 times the inverse sine of x over 5 minus x times the square root of 25 minus x squared. I love this one. It combines an inverse trigonometric function with part of a circle multiplied by a line. I can't remotely imagine what this models in real life. But that's not what we're worried about. Okay, so
Do we have to do implicit? No.
no, this is still a function. If you see y or x by itself, it is a function of either x or y. If there's only a y here, this actually must pass a vertical line test. Joey, what were you going to say?
I don't know, maybe like the position of like the,
I don't even know what this model, yeah. My imagination fails. All right, let's go right to y prime. Let's start writing y prime, but we may have to go off to the side a little bit on this one. 25 arc sine x over 5. The 25 is just a coefficient. That comes along for the ride. From yesterday, what is the derivative of the inverse sine?
1 over 1 minus x. Well, x squared and x squared is x over x.
Root, is this 1 minus or x?
Yeah, 1 minus.
Okay, 1 minus. And that's going to be x over 5 whole thing squared.
And then we needed to do the derivative of x over 5, so just 1.
Excellent. Because 1/5 can be treated as a coefficient there.
Right.
All right. That takes care of the first term. Second term has two factors, each one of which is a different function, meaning what do we put up? Product rule is correct. So I have u.
U prime is 1.
Correct? Give me a sec. Here's my u, here's my v. You understand that's not meant to be a fraction, right? I'm just trying to identify them. All right, so let's see. U prime is 1, comes from the x. V, 25 minus x squared. V prime, or minus uv prime, I should say.
No, it's plus.
Plus, it's the product rule. Thank you. It's not the quotient rule. We were doing the quotient rule a lot yesterday, so it's stuck in my head. X times, what is the derivative of this thing?
Okay, so this is 25 minus x squared, all to the 1/2.
All to the 1/2, right?
So you take a 1/2 down there.
And then it's minus 1.
When after I
With
put
the
it, inside function doesn't change, and then as Michelle's saying,
There's a negative 2x, I think. Is that right?
there is a negative 2x when we finish using the chain rule. Inside function doesn't change. Bring down the 1/2, subtract 1/2 from the exponent, take the derivative of the inside function. And from here, it's just simplification.
Right.
What did I forget that will massively change our answer? Parentheses.
Yeah.
Or brackets around this whole thing because I'm subtracting the derivative of the product of these two functions, so the entire result of the product rule has to be in parentheses, so that I correctly distribute my minus sign. Wouldn't it be nice if we could leave it like this?
Right, but
No. On the other hand, also on the AP exam, how would you like to try and pick between 5 different versions of this with very slight differences?
Well, we know that that's just, 5 over,
Awesome. Michelle is spotting that the 1/5 and the 25 will just leave me a 5 in the numerator. That's going to be over 1 minus
x squared over 25.
x squared over 25. Very good. General rule is, although we usually try to get rid of complex fractions, rarely does anyone bother to go after them inside a radical. Inside here, I'm going to have just the square root of 25 minus x squared plus, let's see, my numerator is going to have negative 2x times x over 2 times the square root of 25 minus x squared. I'm used to when we used to have the camera over there, and I think I'm blocking Jen's view for most of this lesson, so I have to be careful of that. Is this simplified yet?
I don't.
No. This camera setup is hard to move, so we're stuck on one board, so I've got one more line to simplify it. Get a little further. For one thing, I can simplify the 2 and the 2.
Right.
X times x is x squared. Let's take care of that. So y prime is 5 over root 1 minus x squared over 25 minus, I guess see where this is going, but I'll hold off a second. I'm going to make this, I could make a common denominator here. If I put that over 1, let's do that in this step. Oh, can I cross out this 2 and this 2?
Right. I think, yeah. You can do
That-
much.
And that negative will make that subtraction.
It's just x squared.
What would I do to make this a common denominator, this term, a common denominator with this
you
term?
would square the top term and the root 25 minus x squared on the bottom.
Same result. I don't want you to say square the top. I don't want you to think you can make an equivalent fraction by squaring. But you would multiply top and bottom by root 25 minus
Then
x
that would
squared.
just make it 25 minus x squared, minus x squared,
All over.
20, root 25.
Awesome. Still not going to get a common denominator between these two. I don't care enough.
Actually, you know what? I think what you can do.
Combine that x squared.
Is that what Tyler was going to say?
Well,
You're thinking about making a common denominator here?
yeah, I
We
think
can,
I got
actually.
an idea. What you do with that one is multiply both top and bottom by, I guess, root 25, which makes that like.
Very clever, sir. Very clever. I wonder if the back of your book did that. Okay, let's simplify this fraction a bit, and then we'll talk about what Tyler's talking about. 25 minus 2x squared over. There is a way to simplify these denominators. What's the difference between, not so simplify, make a common denominator?
Oh, 25.
If I multiply all this by 25, do I get that? Can I multiply by 25 inside a radical?
No, you got to do it by root 25,
Root 25 will get it inside the radical.
which in non-root terms is just 5.
Very good. Okay, I'm going to show these steps for Daryl and Jen. I don't want to move the camera today, so may I erase this first line?
Yes.
Sorry.
This is going to be rough doing all this on one board. Alright, so going back from here up to the beginning. If I take this first term and I multiply the top by 5 and the bottom by root 25, I'm getting ahead of myself. 5 over root 25 is 1, correct? So I'm just multiplying by 1. That's going to be minus 25 minus 2x squared over the square root of 25 minus x squared. And when I multiply by root 25, that'll become 25 minus x squared. So So I'll wind up with 25 minus, parentheses, 25 minus 2x squared, all over the square root of 25 minus x squared. How's that look so far?
Looks good.
Alright. This is going to be rough on one board today. A lot of them are this long. Okay. Then, how close are we to being done?
We're almost there.
Almost there.
Because we got to,
That's just,
right.
so minus 2x squared.
Minus 2x.
It's
Oh, it's
positive.
positive.
I'm feeling good about stopping there. How about you
Yeah.
guys? Does that look like an answer?
I think, yeah, that looks like a good place. I know.
Well, this one with it even, so I have no way to check in the back of the book. But that looks like a good place to stop. Any questions on that one? Any silly mistakes? Hopefully not.
I don't see any as of yet.
This would be one of the harder multiple choice questions, I think, on an AP exam. And but one of the other choices would be this one with a minus sign. They really
Oh,
want you
right.
to get to the end and start to go where Michelle started to go and not do the minus minus there. That would be neat. All right. That simplified pretty nicely, actually.
Do they ever give you like partial credit, like if
Not on the multiple choice, I believe.
Okay.
Um,
Because like you know how like some problems are closer to the other problems.
That would be kind of nice. I would love it if they would do something like that where there's the correct answer. There's a couple of there's two answers that are smart mistakes and are given some credit, and there's two answers that are
Not, and you
Just-
just don't get anything.
you don't get anything for yet. I would love to see them do that. I've never heard of any standardized test running that way, but I've always thought that would be a very fair way to do it. I'm going to erase this and start over at the top, because if I start writing over there, I will make a mess of the board. And I will try and write this one.
And I don't get pens.
All right. Directions are a little different on this one. Find the equation of the tangent line. Two, should say two rather than of. And the function is, which one do I want to do here? Nah, do a different one. Change my mind in the middle. Y equals 1/2 arc cosine x over 2 at two comma pi over 4. Find the equation of the tangent line to y equals 1/2 arc cosine x over 2 at the point 2 comma pi over 4. All right. Are we sure that point is real? Are we sure that point's on the graph? Do we know how to check that?
Do we have to? Fine.
No, we don't have to, but I just want to do a little trig
Because
review.
I trust them personally.
Why, Joey? Never trust the man. Pi over 4 is the y value, right? And that should equal 1/2 inverse cosine of 2 over 2. Did I plug those in correctly?
Yep.
Okay, when is the
Just go send 2 over
when is the cosine equal to 1 and how many degrees?
At 0.
Zero.
2.
No, yeah, just 0.
Okay, one.
So cosine of 1 should be an angle of,
Well, it's inverse. I mean, it's.
that doesn't look right.
Read the problem.
Could be 0 or
Let
pi.
me make sure I've got the right one here. And I'm glad I checked because I did plug it in correctly. something looked wrong, and I was correct that it was wrong. I didn't think that y and x worked out. So let's try this again. Rewind, take 2. 1/2 arc cosine x at. See, Joey, you could trust the book, but it turns out you couldn't trust me.
Damn.
I know, I hate it when that happens. I think I've been doing this a little too long when I look at that expression and realize that that point can't be on that inverse graph. I'm triple checking now. 1/2 cosine x, inverse cosine x, negative root. Okay, does this one work? You want to trust me this time?
Yeah. I go with
So
you this.
3 pi over e equals 1/2.
Cos or
Inverse
cosine
cosine of.
negative root 2 over 2.
Okay, where is cosine negative root 2 over 2? Now let's go with the principal value, the first one on the unit circle we hit. It's in quadrant 2. What's a reference angle?
It's, the reference angle is
3 pi over 4.
You jump to the standard angle. Yeah, the reference angle is pi over
Oh,
4,
it's pi
45
over 4,
degrees.
yeah.
The
So
standard
you-
angle, very
3
good,
pi
is
over
3 pi over 4,
Divide
Divide
135
that by
degrees.
2 is 3 pi over 8.
So this is going to be 3 pi over 4 times 1/2 will be 3 pi over 8.
okay.
We good?
Yep.
All right. Okay, now, what was the question again? Find the equation of the tangent line. What's the first thing we need to know to find an equation of a tangent line?
The derivative.
That's what I was thinking. Yeah.
Yep. Very true. So this is y prime will be, bring the 1/2 along for the ride. What is the derivative of inverse cosine?
It's negative 1 over root 1 minus x squared, and it's actually x squared.
It actually is x squared this time, and we don't have the derivative or inverse function is just 1, so we don't have to worry about it. Chain rule is not a problem here. And all of the complementary functions, cosine, cosecant, cotangent, are the negatives of the derivatives of sine, secant, and tangent. Slightly different pattern to memorize or learn or rederive here. Okay, so this tells us the slope of our tangent lines in general, but we're interested when x equals negative root 2 over 2, correct?
Absolutely.
All right, so y prime of negative root 2 over 2 is 1/2 times negative 1 times the square root of 1 minus,
Root 2 over 2 squared.
and negative root 2 over 2 squared, but it will work out to the same thing. Okay, so
Kind of see what
I see some possibilities.
When you,
Go ahead.
the root 2 squared just become 2 over 4, so 1/2.
Okay, so that's going to be negative 1 over root 1 minus 2, 4. So we're looking at 1/2 times negative 1 over root 1/2.
Which would be either plus or minus root 2.
You're already simplifying this thing? Don't worry about the plus or minus yet. So, yeah, there's square root of 1/2. A couple different ways we can look at this. 1 over root 1/2, it is going to turn into a root 2 when we're done. So let me write this correctly. So y prime of negative root 2 over 2 is going to be 1/2 times. One way to look at this, take the negative 1 out, and what's left is 1 over.
Wait, what happened to your number?
I was going to put it in parentheses, but I'll leave it as a radical. Can I do this? Can I, if I take the negative out, can I put this whole thing under a radical without changing anything?
I mean, square root of 1 is 1.
Since the square root of 1 is 1, that works
Wait a
nicely.
minute. Whoa.
And what's 1 over 1/2?
It's just 2. Oh my god.
Just 2, wow. I just wanted to prove the point. Tyler was there a minute ago, but I wanted to demonstrate it for everyone else.
Wait, so can you do that with any Like,
as long as it's
let's
one.
say it's like 1 over 5, like in your radical underneath. Instead of like it being 1/2, it's like 1/8. Then you can do kind of.
Yep.
But let's say it had like -2 on the top. You can still see like a negative.
I would take the whole -2 away and leave a 1 on
2,
top.
okay.
So yeah, you can. This is a pretty universal trick. So as Tyler said, the slope of our tangent line is -√2/2. That's a little coincidental, because unless we've made a horrible, horrible mistake somewhere, it's the same thing as our x-coordinate.
Can that happen?
No, that's not a pattern for this.
No, not a pattern, but like can that happen?
Yeah. In fact, it's a little bit predictable. I know we're looking at inverse sines and cosines, but you know how the derivative of sine is cosine, and the derivative of cosine is negative sine? Well, when do sine and cosine equal the same thing? At what angle?
At pi over 4.
Pi over 4, and also at 5 pi over 4.
Yeah.
3 pi over 4, they're opposites. So, and these are the inverses. So, the sines and cosines of some angles are the same. So when you invert that, the arc cosines and arc sines of some angles are the same. So because they're related, you should expect that basically at something like that at all multiples of 45 degrees, whether you're deriving sines or cosines or inverse cosines. Does that make sense? Only because we're at a multiple of 45 should we have expected something like that. Okay. All we know now, though, is that we're looking at a line that looks like y equals -√2/2x plus some y-intercept. We can also do point slope form. That would be a little easier, probably.
Yeah, I can.
Yeah. Jen doesn't like point slope form, but it didn't say what form to leave the equation in, so
You already have your 2 points.
perfect, yeah. So I would just say,
Y minus 3 pi over 8 equals -2/2.
-√2/2
Oh yeah, times x plus.
plus √2/2. And if the AP exam is kind enough to give you your choices in point slope form, please expect all of these signs to be different, and maybe a 3 pi over 8 and a √2/2 to be switched. So be careful with the silly mistakes, because they're good at predicting them. I want to do this one a different way as well, and let you guys pick. Everyone comfortable with this? Take a moment, let it sink in, perhaps even silence a phone. It was actually from Jen. I needed to give you guys back that last test you took, and she finally started pestering me about it. I've had them for a while. Okay, I can erase this now?
Yes, sir.
Awesome. Okay,
That's good.
let's try something else and you can tell me which one you like better. This will reinforce a different point you'll need to know soon. My board is dying, it's getting harder to erase. Okay. What's the inverse of y? It does, it's got a coating that actually does fade with time. I've had that replaced before. Invert this for me. X at y equals 1/2 arc cosine of x. How do we invert any function? What do we do first?
Switch the line at.
Joey is doing interpretive dance, but it's the same idea. X equals 1/2 inverse cosine of y. What's my next move?
And then
Get y by itself.
Yep. So there's 2x equals inverse cosine of y.
When you multiply each side by cosine, just cosine.
Oh, you will get the answer right, but your verb choice. These are transcendental functions.
I don't know. You do something. You get cosine.
It's a little bit like with logarithms, where I say what you're really doing is rearranging the information. You're not multiplying or dividing. These are transcendental functions. You can't think of them as behaving like anything on the order of operation. So the end result will be, I have no doubt you would have written down the right answer, that the end result will be y equals cosine 2x, right?
Yes.
Okay, but you're not multiplying, you're not dividing. You can think of it as taking the cosine of both sides. That's an okay way to think of it. But really, it's like what I was saying about logarithms. You're just rearranging. This is an inverse cosine, so this statement literally says y equals the cosine of 2x. This is the ratio, and 2x is the angle. So now this is the ratio, and 2x is the angle, and we're taking the cosine of it. What is the derivative of cosine 2x?
2. Oh, no, cosine 2x.
Yes, where did I go? It's okay. You're doing
Okay, negative sine 2x, 2.
y prime is negative sine 2x, and I know you were just jumping to the derivative of the inside function there. So that's negative 2 sine 2x. Here's where I wish I could write left-handed when the camera's on that side. Okay, y equals negative 2 sine 2x. This is a point on the inverse cosine. What is the corresponding point on the original cosine function?
Oh, the x and the y's change.
Yes. Yes,
so
yes, yes.
then, the root 2 over 2 becomes your y. The negative root 2 over 2 becomes your y value.
Yes, and if you open your imagination a bit, inverse trig is kind of the easiest place to see this. Because for this arc cosine function, an inverse cosine, the x has to be the ratio and the y has to give you an angle. That's what inverse trig does. You put in the ratio, you get the angle back. For trigonometry, you need to put in the angle and get the ratio back. So 3 pi over 8 had better be our x. Okay? What is, for this inverse function, what is y prime of 3 pi over 8 going to be?
It'd be negative 2 sine 6 pi over
2 times, 3 pi over 8. Instead of 6 pi over 8, can I reduce the 2 pi and a fourth?
Move that 3
Wait, is this y prime or y?
Y single prime.
pi. Because you're
No,
just
why is it y?
Oh, because
Because I am
Thank
getting
goodness.
old, and early onset senility is a very sad thing. Also known as I messed up. Okay, what is sine of 3 pi over 4?
2 over 2.
Root 2 over 2. What happens when I multiply root 2 over 2 by negative 2?
It becomes negative root 2.
What is, for answering this original question, what was the point of inverting the function and deriving it, and finding the slope of the tangent line on the inverted function after switching the x and y?
Oh, then you just have to take the reciprocal.
Then we take the reciprocals. Was that really confusing thing on the first
Then
stage?
you're left with negative 2 over
Let me write this out. Let me write this out symbolically first, but
1 over 2.
See-
Negative.
you got it. Okay, so if f prime of 3 pi over 8 equals negative root 2, then I know that f, Michelle, which notation did you like best?
It doesn't matter.
Okay, then I know that f inverse prime, not a 1, it's an apostrophe,
Thank you.
of negative root 2 over 2 is 1 over negative root 2, which after I rationalize is going to be negative root 2 over 2. 2 ways to find the slope of the tangent line. First way, we derived the given inverse trigonometric function. And we found that when x was negative root 2 over 2, f prime was also negative root 2 over 2. Second way, take your inverse trig function, invert it to get back to a trigonometric function. Derive that. Down here. Here's the part that's easy to mess up. The x value on our given inverse trig function is a y value on our inverted function and vice versa. So we don't take the derivative at negative root 2 over 2. That's the x value on the arc cosine. We take the derivative of the cosine function at 3 pi over 8. The y value on the inverse is the x value on the inverse of the inverse cosine. Find that, take the reciprocal, find the slope that way. Again, point slope form would be fastest from here. I don't know which one of these you guys would consider easiest at this point. You have been doing the derivatives of cosines longer, so they're more familiar probably. If you forget those rules for the inverse trig, you can do something like this if it's finding the slope of the tangent line. If it's just find the general derivative, this won't help you unless you're going to use it to go back and rederive the whole thing from the triangle. If you're on a test and you have the time and you don't have any other answers, there's nothing wrong with that. Do you guys understand each method? Do you have any questions on each method? I don't actually think the math on this is that hard, but every time I try to explain, especially that you switch the x's and y's on which one you use for your plug into the derivative, I always feel like I start speaking gibberish, and I apologize for that. Especially this one, where you start talking about, after you invert the inverse, you get the original back, and then you have to invert the points. But if you keep track of when you're talking about an angle and a ratio, and when you're talking about an angle and a ratio, that helps me remember it on these. Just out of curiosity, for this particular one, which one would you guys have preferred to do? First one?
Like I would, this had not
This
occurred to me.
seems roundabout a bit.
Because
It is roundabout.
Because I know that the other one you just need to remember what the arc cosine is.
You just need to remember those three patterns. You need to remember sine, secant, tangent, and then the negatives, cosine, cosecant, cotangent.
Like if you remember those, then you're fine. Because this you have to remember to flip them, and then you have to remember to go and do the
Reciprocal at the end.
and then you have to go back to plug it into.
Gotcha. We're not going to do that for this test, but when we prepare for the AP exam in a few weeks, when we start preparing, this trick is going to be necessary because they're going to give you some problems where they just give you data and there's no actual finding the derivative. They'll tell you some f's and f primes, and they'll say, tell us what f inverse of is at this point. So you can't forget this trick, but this is roundabout. I was going very slowly and overshowing the algebra, I think, on this, or the trigonometry, but a lot of times this is fewer math steps. It's the only plug I'll make for it. I'm not going to push you guys to do it any particular way unless I have to.
Like if I'll try this. Like see which one
Might be fun. I think that covers. I did one hideous general find the derivative, and I did this two different ways. And I'm just going to tell you the homework now, which you can start is page 380, and this homework is online. I haven't changed anything this week. 55 to 67 odd. So check your answers, go to Calc Chat, and I think that's it.